Today we're going to be talking about how we can solve linear systems using what's called the echelon method. So what is the echelon method? The echelon method is a method of solving a system of equations using transformations to rewrite the system in triangular form. This method is also called back substitution. Now, what do we mean by transformations of a system? So equations in a system can be transformed to get what we call an equivalent system. We can do this by exchanging any two equations, so you could write one equation first, the other equation second, or it could be the other way. It doesn't change the system itself. You can multiply both sides of an equation by any non-zero real number. We've done that before. When it comes to elimination, you can multiply an entire equation by 2. That is one form of transformation. You can replace any equation by a non-zero multiple of that equation plus a non-zero multiple of another equation. So we can actually take one equation, a non-zero multiple of that equation, add it to another multiple of another equation, add them together, and get another resulting equation that we can then put in for our system. So in triangular form, what does this actually look like? Why is it called triangular form? So for a system of two equations and two variables, this is what triangular form looks like. We have x plus ay equals b, and y equals c. Now for a system of three equations and three variables, this can actually visually help you understand why it's called triangular form. So you would have x, y, and z as your variables, and this is what triangular form would look like. You would have x plus ay plus bz equals c, followed by y plus dz equals e, followed by z equals f. Now you'll notice in the first equation we have x, y, and z. In the second equation we only have y and z, and in the last equation you only have z. Now a, b, c, d, e, and f, those are all just constants. They are actual numerical values, but we're trying to generalize this here. So in triangular form, back substitution is used. What do I mean by back substitution? Well, once you get something in this triangular form, that very last equation that you have, whether you have two equations and two variables or three equations, three variables, the last equation always has one of the variables equals a numerical value. You'll notice in the first one we have y equals c, and in the second one we have z equals f. If you know what that value is, now you can go back and substitute. This is why it's called back substitution. So for example, take y equals c. Since you know what y is equal to, you can plug that in, you can go back and substitute in for y and plug c in, and you'll get the value of x that way. Same with the three equations and three variables. You know what z is equal to, so you can go back to the equation before that, plug in for z, solve for y, and now you have both y and z. And now that you have both y and z, you can now go back to the first equation, plug in for y and z, and you'll be able to solve for x. Let's take a look at an example. So solve the following system using the echelon method. So in order to get this into triangular form, we need to eliminate the x term. So how do we do that? Well, exactly how you would do this if you were using elimination. So let's take the first equation and multiply by 11. Multiply the second equation, multiply by -3. Alright, now if we were to multiply this all out, we'd end up with 33x plus 110y equals 1265. And the second equation would be -33x minus 12y equals -285. And now we can eliminate x. Alright, so eliminating x, that leaves us with 98y equals 980. And now we're going to finish putting the system in triangular form and then solve from the bottom of the triangle and back substitute. So 3x plus 10y equals 115. Now this is almost completely in the correct form. You'll notice if you go back to the general form that I wrote down, we had no number in front of x. So we need to here divide everything by 3 or multiply everything by 1/3 so that we have x by itself. So multiply this and we end up with x plus 10/3 y equals 115 over 3. And then for this equation here, we have y equal to 10. So that's triangular form. X plus 10/3 y equals 115 over 3, and y equals 10. Now, we're going to go ahead and back substitute. So since we found y equals 10, now we're going to plug 10 in for y in the equation above it, and that leaves me with x plus 10 over 3 times 10 equals 115 over 3. That leaves me with 100 over 3. Subtract that from the other side, and that leaves me with x equals 5. So our answer here is 5, 10. So x equals 5, and y is equal to 10. Now we do have the special cases where you either have no solution or an infinite number of solutions. So what happens when you're using the echelon method to solve and you have one of these cases? So if both variables are eliminated in the bottom equation and you are left with a false statement, then you know that the system has no solution. On the other hand, if both variables are eliminated in the bottom equation and you are left with a true statement, then the system has an infinite number of solutions. Let's see if we can look at an example and see what this looks like. We have 2x minus 3y equals 6, and negative 4x plus 6y equals 8. Now to get this in triangular form, we have to eliminate the x term. So naturally, when you're trying to eliminate the x term, it looks like you would probably want to multiply the first equation by 2. That leaves us with 4x minus 6y equals 12 for the first equation. I'll write the second equation right below it. And then we are going to add. And what ends up happening when we try to eliminate the 4x and the minus 4x, that gets eliminated, but so does the negative 6y and the 6y. So that leaves us with 0 equals 20. All right, now we're going to finish putting the system in triangular form. Now, we already know that the bottom of the triangle gives a false statement, but just for practice, we'll put it in triangular form. So 2x minus 3y equals 6 was the original first equation. But remember that we're going to need to divide everything by 2 so that the x term does not have a coefficient in front. So multiply this by 1/2 and we end up with x minus 3/2 y equals 3 and 0 equals 20. So that's in triangular form. Now obviously because we ended up with a false statement, we know that our solution here is that there is no solution. Let's do another example. 3x minus y equals 4, and negative 6x plus 2y equals negative 8. All right, to get this in triangular form, let's start by eliminating the x term. So in this case, it looks like we want to multiply the first equation by 2. So that leaves us with 6x minus 2y equals 8. And on the bottom, we have negative 6x plus 2y equals negative 8. And we'll go ahead and eliminate the x term. You'll notice here now that when we eliminate the x term, we actually also eliminate the y term and everything on the right. So we end up with 0 equals 0. Now since we know this is a true statement, we actually already know that this has an infinite number of solutions. Just for practice, we'll put this into triangular form anyway. So our top equation was 6x minus 2y equals 8. And we had 0 equals 0. So for that first equation, again, we don't want to have a coefficient on x. So multiply this by 1 over 6. So we have x minus 1/3 y equals 4/3. And then 0 equals 0. So that's triangular form. And we said that because we get 0 equals 0, everything gets eliminated. And we have a true statement, this has an infinite number of solutions. Okay, we have one last example. This is an application problem, and we are going to solve this by using the Echelon method. A flight leaves New York at 8 p.m. and arrives in Paris at 9 a.m. Paris time. This 13-hour difference includes the flight time plus the change in time zones. The return flight leaves Paris at 11 p.m. and arrives in New York at 3 p.m. New York time. This 2-hour difference includes the flight time minus time zones, plus an extra hour due to the fact that flying westward is against the wind. Find the actual flight time eastwards and the difference in time zones. Alright, so let's start with the two things we're trying to find: the actual flight time and the difference in time zones. So I'm going to call those two x and y. So I'm going to make x the flight time going east and y the difference in time zones. Now, it says here that a flight leaves New York at 8 p.m. arrives in Paris at 9 a.m. Paris time. This 13-hour difference includes the flight time plus the change in time zones. So the flight time going east to Paris plus the difference in time zones, that is going to equal 13. So that's going to be my first equation. X plus y equals 13. All right, now for a second equation, we're told the return flight leaves Paris at 11 p.m. and arrives in New York at 3 p.m. This 2-hour difference includes the flight time minus time zones plus an extra hour. So we say that this is the flight time, that's x, minus the time zones, that's y, plus an extra hour, that's 1, plus 1 hour, because flying westward is against the wind, so it's going to take longer. So x plus the 1 extra hour minus the difference in time zones is going to equal 2. So now I actually have two equations, two variables, and I'm going to go about solving this by putting it in triangular form first and then back substituting. Alright, so x plus y equals 13 is the first equation, and just simplifying the second equation, we have x minus y equals 1. So to get anything in triangular form, you're always going to eliminate the x terms. So I'm going to multiply this bottom equation by -1. Alright, x plus y equals 13, and negative x plus y equals -1. We're going to eliminate the x term. That leaves me with 2y equals 12. Y equals 6. Now to write it in triangular form, I would write that first equation, which actually already has x without a coefficient in front, so just x plus y equals 13, and y equals 6. There's triangular form. And now I'm going to substitute, go back and substitute, so back substitute, that 6 back into x plus y equals 13. So x plus 6 equals 13, which means x equals 7. Now let's put this back into the context of the problem. X represented the flight time going east, and y represented the difference in time zones. So the flight time is 7 hours, and the difference in time zones is 6 hours.